Now in this lecture we'll find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB of this quadrilateral is equals to 2 units in its length. Side BC equals to 8 units in its length. And side DC equals to also 8 units. This is angle ABC that is equal to 90 degrees in its size. It is a right angle. And this is angle DCB that is also equals to 90 degrees. Again, our mission is to find out the area of this circle. So, first of all, we'll do a construction. That is to say, we will extend side DA and side CB of this quadrilateral until they touch each other. So actually, this is the touching point of the extended side DA and the extended side CB. We'll define the touching point, this point is point M. We define this angle is theta, and we will focus on the right big triangle DCM. On this big right triangle DCM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. At 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Here, CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and the result is CM. So CM, so when you extend a straight line by straight line, the result must be a straight line. Therefore CM is a straight line. So if we focus on the upper side of the straight line CM here at point B, so the sum of the angles in the upper side of CM at point B must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is a right angle, it is equal to 90 degrees, plus the missing angle that is actually angle ABM. So this missing angle, ABM, in total the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. So the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we'll focus on the small right triangle ABM. And the small right triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we'll prove that the right big triangle, triangle DCM, is similar to the right small triangle, triangle MBA. So write it down. We'll prove that the right big triangle, triangle DCM, is similar to the small right triangle, triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle DCM in the right triangle DCM. And it is equal to this angle, that is actually angle ABM in the right small triangle MBA. Repeat again. Angle DCM in the right big triangle DCM equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. That is a common angle. It belongs to both triangles. So angle theta equals to itself. It's a common angle that belongs to both triangles. So if we relate to angle theta as it belongs to the big right triangle DCM, it will be defined as angle DMC. And it equals to itself. So if we define, if we look at angle theta as it belongs to the small right triangle MBA, it will be defined as angle AMB. This again. This equation means that angle theta equals to itself. We just call to angle theta two different names. So angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MDC. And it equals to this angle, that is actually angle MAB. In the right small triangle MBA. Repeat again. Angle MDC in the right big triangle DCM is equal to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles in the small right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The right big triangle DCM is similar. This is the sign of similar to the right small triangle MBA. According to angle, similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side DC in the big right triangle DCM over side AB in the small right triangle MBA is equals to side CM in the big right triangle DCM over side BM in the small right triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. According to what is given as the question, side DC equals to 8 units in its length. So we substitute DC by 8 over AB. According to what is given as the question, AB equals to 2 units in its length. So we substitute AB by 2. And it is equals to CM. What is CM? CM is CB plus BM. That is to say, CM is CB that is equal to 8 units in its length according to what is given as the question, plus BM. So in total, CM equals to 8 plus BM. And so we substitute CM by 8 plus BM divided by BM. So we can find out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, and we get that 4 times BM equals to 8 plus BM. Here we subtract BM from this equation, and we get that 4 times BM minus BM is 3 times BM, so 3 times BM equals to 8. Here we divide this equation by 3, and finally we get that BM equals to 8 over 3 units in its length. BM equals to 8 over 3. So I can write down in the original drawing that BM equals to 8 over 3. Here, this line segment BM equals to 8 over 3 units in its length. In the next step, we'll implement the Pythagoras theorem on this right small triangle, triangle MBA. So here by PT is the proportion for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM, so the square of the hypotenuse is AM squared. and it is equals to AB square plus BM square. In conclusion, we found out that moving to the quadratic one, AM square equals to AB square plus BM square. So AM square equals to AB square. AB is 2, therefore AB square is 2 square, that is 4, plus BM square. We just right now found out that BM equals to 8 over 3, therefore BM square is 8 over 3 square, that is actually 64 over 9. Here we multiply 4 by 9 and then we divide it by 9 in order to have a common factor with 64 over 9, and we get that AM square equals to 9 times 4 is 36. So in total, in the numerator of this expression, we have 36 plus 64 over 9. 36 plus 64, it is 100, so it is 100 over 9. And we found out that AM square equals to 100 over 9. Here we take a water out of this equation. And finally, we get that AM equals to the square root of 100 over 9. The square root of 100 is 10, and the square root of 9, is 3. So we found out that AM, that is the hypotenuse of the right triangle MBM, equals to 10 over 3 units in its length. AM equals to 10 over 3 units in its length. Again, AM equals to 10 over 3 units in its length. Now, in the next step, we'll do another construction. That is to say, we'll draw perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. It is absolutely possible to do it because we can find point on BC in such a way that the perpendicular will be also tangent to BC, and the perpendicular will be perpendicular to BC, and also the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular on BC as T, and we define the point of tendency of the perpendicular with this circle as K. We will extend the perpendicular TK on a straight line until it touches side AD. And we will define the touching point of the extended perpendicular TK with side AD as point L. By doing this construction, we can get here the right triangle MTL. The right triangle MTL, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we define the center of this circle, this point as O. We define the point of tendency of tangent BT with this circle as H. And finally, we define the point of tendency of tangent AB with this circle as M. In the next step, we join points O and H together by a straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of this circle. We define the radius of this circle as x, therefore OH equals to x. This is the radius of the circle. You can implement here rule 1, repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. In the drawing, we have a circle, and we have also here tangent AB, that is tangent to this circle, is point M. Point M is the point of tendency. And we have here the radius OM, that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule 1. You can implement rule 1 in our drawing. Right, because in our drawing we have the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and N together by a straight line. Line segment ON is the radius of this circle that is equal to x according to our definition. Again, the radius ON is drawn to point N. Therefore, according to rule 1, this angle equals to 90 degrees. And this angle also equals to 90 degrees. Likewise, we join points O and K together by a straight line. Line segment OK is the radius of this circle that is equal to x. Again, the radius OK is drawn to point K. Therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will focus on this small quadrilateral OKHT. In this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles in this small quadrilateral OKHT to 360 degrees, the missing angle here must be equal to 90 degrees. So inside this quadrilateral OKHT, we have 4 right angles. The 4 can relate to this quadrilateral is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OKHT, side OK must be equal to the opposite side HT. But OK is x, therefore HT must be also equal to x. Likewise, in rectangle OKHT, side OH must be equal to side KT. But OH is x, therefore KT must be also equal to x units in its name. So we can find out that quadrilateral OKHT, this small quadrilateral, is not a rectangle but a square. Why? Because all of its sides are equal to each other, each side equals to x. We repeat on the same process on this four quadrilateral NOBH. In this quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So quadrilateral HBNO has 4 right angles, therefore we can relate to this quadrilateral as a rectangle. And we know that the opposite sides of rectangle are equal to each other. That is to say, side ON must be equal to the opposite side BH. But ON is x, therefore BH must be also equal to x units in its length. And we know that the opposite sides of a rectangle are equal to each other, so the opposite sides of a rectangle NOBH must be equal to each other. That is to say, side NO must be equal to the opposite side BH. Also, side OH must be equal to the opposite side NB. But OH is x, therefore NB must be also equal to x units in its length. So actually found out that quadrilateral NOBH is not a rectangle but a square one because all its sides are equal to each other. So in conclusion, found out that BT equals to x plus x, that is 2x. So I'll write it down. The length of line segment BT equals to 2x. BT equals to 2x. In the next step, we'll prove that the right big triangle LTM is similar to the right small triangle MBA. So I'll write it down. We'll prove that the right big triangle LTM is similar to the right small triangle, triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is actually angle LTM. In the big right triangle LTM, and it is equal to this angle, that is actually angle ABM. In the right small triangle MBA. Repeat again. Angle LTM in the big right triangle LTM equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle theta as it belongs to the right small triangle LTM, it will be defined as angle LMT. It equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. So angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle ALT. This is angle, actually, this angle is angle MLT. In the big right triangle LTM, and it is equal to this angle, it is actually angle MAB in the small right triangle MBA. So, I'll do it again. Angle MLT in the big right triangle LTM equals to angle MAB in the small right triangle MBA. They're both equal to 90 degrees, 1 theta, therefore they're equal to each other. So we actually proved that all the three angles of the big right triangle LTM are correspondingly equal to all the three angles of the small right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rules. So I write it down. So the big triangle, the big right triangle LTM is similar. This is the sign of similar to the right small triangle MBA. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side LT in the big right triangle LTM over side AB in the small right triangle MBA is equals to side TM in the big right triangle LTM over side BM in the small right triangle MBA. Repeat again. We derive that LT over AB equals to TM over BM, and also that side LM in the big right triangle LTM is equal to side AM in the small right triangle MBA. So in conclusion, found out that LT over AB equals to TM over BM, and it is equals to LM over AM. LT is the missing side, so we leave it as it is. Over AB, AB is 2, so we substitute AB by 2 in this equation, and it is equal also to TM. What is the length of TM? From the drawing, it is very easy to see that TM equals to TB plus BM. So TM equals to TB, that is 2x, plus BM, that is 8 over 3. So in total, TM equals to 2x plus 8 over 3. So we substitute TM by 2x plus 8 over 3 divided by BM. BM equals to 8 over 3, so we substitute BM by 8 over 3 in this equation. and it is equals to Lm over Am. What is the length of Lm? From the drawing it is very easy to see that Lm equals to in total to La plus Am. That is to say Lm equals to La, that is the missing side, plus Am, that is 10 over 3. So in total Lm equals to La plus 10 over 3. So we substitute Lm by La plus 10 over 3. Lm equals to La plus 10 over 3 divided by Am. Am is 10 over 3, so we substitute Am by 10 over 3. Those two sides that are equal to each other, so we get the equation 1 from those two sides that are equal to each other. So according to equation 1, we get that Lt over 2 equals to 2x plus 8 over 3 over 8 over 3. So Lt over 2, according to the first equation, equals to, here we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. So 2x times 3 is 6x, so in total, in the numerator of this expression, we have 6x plus 8 divided by 3, and also we have to divide it by 8 over 3. So in this side of the equation we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we left only with Lt over 2, that is equals to 6x plus 8 over 8. Here we cross multiply this equation and we get that 8 times Lt equals to 2 times, and inside the brackets we have 6x plus 8. Here we divide this equation by 2 and get that 8 over 2 is 4, so in total on this side of the equation we have 4 times Lt. That equals to, on the other side of the equation we have 2 over 2 is 1, so we left here on the other side of the equation only with 6x plus 8. In conclusion, further that 4 times Lt equals to 6x plus 8. Here we divided this equation by 4. And finally we get that Lt equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion, further that Lt equals to 1.5x plus 2. So this line segment Lt equals to 1.5x plus 2. We continue to focus on the long equation. This long equation, those two sides, they are equal to each other. So we get equation 2 from those two sides that are equal to each other. And we get that according to equation 2, 2x plus 8 over 3 over 8 over 3 is equals to La plus 10 over 3 over 10 over 3. So in this side of the equation we have 2x plus 8 over 3. So we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So in the numerator of this expression in total we will have 2x times 3 is 6x. So it is 6x plus 8. That's what we have in the numerator of this expression, all divided by 3, and we have to divide it by 8 over 3. And it equals to LA plus 10 over 3. Here we multiply LA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. 3 times LA is 3LA plus 10. That's what we have in total in the numerator, divided by 3 over 10 over 3. So in this side of the equation we have 3 in the numerator and 3 in the denominator, so 3 get cancelled. On the other side of the equation we have also 3 here in the numerator and 3 in the denominator, so 3 will also get cancelled. So what is left on this equation after we cancelled 3 on both sides of the equation? We have here, we left only with, in this side of the equation we left only with 6x plus 8 over 8. This equals to, on the other side of the equation we have 3LA plus 10 over 10. So here we'll cross multiply this equation and we'll get that 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divide this equation by 2. And finally we get that 10 over 2 is 5. So in total this of the equation we have 5. Inside the brackets we have 6x plus 8. That is equals to, here 8 over 2 is 4. So in total on the other side of the equation we have 4. Inside the brackets we have 3LA plus 10. So here we'll open the brackets on both sides of the equation. We'll get that 5 times 6x is 30x plus 5 times 8 is 40. That is equals to 4 times 3LA is 12LA plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled and we left only with, in this side of the equation we have 30x, that is equals to 12LA. Here we divide this equation by 12. And finally we get that LA equals to 30x over 12. 30x over 12 is 2.5x. So in conclusion, found out that the length of side LA is 2.5x. So I'll write it down in the original drawing that LA equals to 2.5x. This line segment LA equals to 2.5x in its length. In the next step, I will copy the small quadrilateral ALBT in a new page with the circle that is inscribed in it, and we'll analyze this quadrilateral ALBT. So actually, this is quadrilateral ALBT that I call it from the original drawing. You can implement here rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing we have a circle and also the common standpoint point P. From the common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. For the lengths of those two tangents, they are equal to each other. PA equals to PB. We can implement rule 2 in our drawing. Why? Because, but before that, we define the point of tendency of tangent AB with this circle as K. We define the point of tendency of tangent BT with this circle as point S. We define the point of tendency of tangent LT with this circle as H. And finally, we define the point of tendency of tangent AL with this circle as M. So here we can implement rule 2. Why? Because if we focus on the common standpoint point A, from the common standpoint point A, we have two tangents to this circle, tangent AN and tangent AK, and according to rule 2, they are equal to each other. So AN equals to AK according to rule 2. So if we define, again, AN equals to AK according to rule 2. So if we define the length of AN as A, then the length of AK must be also equal to A because they are equal to each other. So AN equals to AK equals to A. In the next step, we'll focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this circle, tangent BK and tangent BS. And according to rule 2, they are equal to each other. That is to say, BK equals to BS. We can write here that BK equals to BS. According to the same rule, rule 2. So if we define the length of tangent BK as B, then the length of tangent BS must be also equal to B because they are equal to each other. So we found out that BK equals to BS, and it is also equals to B. Likewise, if we focus on the common standpoint point T, on the common standpoint point T, we have two tangents to this circle, tangent TS and tangent TH. According to rule 2, they are equal to each other. So TS equals to TH, according to the same rule, rule 2. So if we define the length of TS as C, then the length of tangent TH must be also equal to C because they are equal to each other. So in conclusion, found out that TS equals to TH equals to C. And finally, we'll focus on the common external point L. For the common external point L, we have two tangents to this angle, tangent LN and tangent LH. And according to all two, they are equal to each other. So LN equals to LH according to the same rule, all two. So if we define the length of tangent LN as D, then the length of tangent LH must be also equal to D because they are equal to each other. So in conclusion, we found out that LN equals to LH equals to D. Okay. So in the next step, we'll add side AB to side LT. Okay. So AB, we'll add side AB to the opposite side, side LT. What is the value of AB plus LT? From the drawing, it is very easy to see that AB equals to A plus B and LT equals to C plus D. Therefore, in total, AB plus LT will be equal to A plus B plus C plus D. So AB plus LT equals to A plus B plus C plus D. In the next step, we'll add side AL to side BL, and we'll add side AL to side BT on this quadrilateral AL BT. So AL plus BT. What is the total value of AL plus BT? From the drawing, it is very easy to see that AL plus BT is actually equals to A plus B plus C plus D. So AL plus BT equals to A plus B plus C plus D. So we actually found out that those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. Okay. So the expression AB plus LT equals to the expression of AL plus BT. Repeat again. Found out that AB plus LT equals to AL plus BT. Again, AB plus LT equals to AL plus BT. AB equals to 2, therefore we substitute AB by 2 plus LT. LT, this is line segment LT, is equals to 2 plus 1.5x. So we substitute LT by 2 plus 1.5x. And it is equals to AL. AL equals to 2.5x. Therefore, we substitute AL by 2.5x. Here, AL equals to 2.5x. Plus BT. Here, this is line segment BT. This is equals to x plus x, that is 2x. So BT equals to 2x. Therefore, we substitute BT in this equation by 2x. In conclusion, found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. So 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x, that is equals to, in the other side of the equation we have 2.5x plus 2x, that is 4.5x. So here we subtract 1.5x from this equation, and we get that 4.5x minus 1.5x is 3x, that equals to 4. So 3x equals to 4. Here we divide this equation by 3. And we get that x equals to 4 over 3 units in its length. So the radius x here, the radius x of this circle equals to 4 over 3 units. Our mission is to find out the area of this circle. And we know that the area of any circle is pi times the radius square. So in our specific case, the radius of the circle will be equal to pi times r square. The radius is x, therefore the radius square is x square. So the area of the circle equals to pi x square. And we just write our formula that x equals to 4 over 3. If x equals to 4 over 3, then x square will be equal to 4 over 3 square. So here the area of the circle will be equal to pi, and x square is 4 over 3 square. So the area of the circle in total will be equal to pi times 4 over 3 square. 4 over 3 square is 3 square, that is 16. Again, 4 over the area of the circle equals to pi times 4 over 3 square. And 4 over 3 square equals to 4 square, that is 16, over 3 square, that is 9. So we're going to find out that the area that we are looking for, the area of this circle, it is either equals to 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. And that is the answer to our question. Okay. And again, the area of the circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. In the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that side AB equals to 2 units in its length, side BC equals to 8 units in its length, and side DC also equals to 8 units in its length. This is angle ABC, this is equals to 90 degrees in its size, and this is angle DCB, this is also equals to 90 degrees in its size. It is a right angle. Again, our mission is to find out the area of this circle. So in order to find out the area of the circle, we did a construction, that is to say we extended side DA and side CB of this quadrilateral by a straight line until they touch each other. We define the touching point as M. So by doing this construction, we created here the right big triangle, triangle DCM. We focus on the right big triangle, triangle DCM. We define this angle, that is actually angle DMC as theta. So in the right triangle DCM, this angle equals to 90 degrees, this angle equals to to theta, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Then we know that BC or CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and the result is CM. CM must be also a straight line. Why? Because when you extend the straight line by straight line, the result must be a straight line. So CM is a straight line. Then we focus on the upper side of the straight line CM at point B. Here the sum of the angles must be equal to 180 degrees according to the rule. Then the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have in the upper side of CM at point B? We have this angle that is 90 degrees plus the missing angle that is angle ABM. In total, the sum of those angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. So in the right small triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that the right big triangle DCM is similar to the right small triangle ABM. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the three angles of the right triangle DCM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles can go into each other according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. That side DC on the big right triangle DCM over side AB on the small right triangle MBA equals to side CM on the big right triangle DCM over side BM of the small right triangle MBA. I repeat again, we derive that DC over AB equals to CM over BM. DC is 8 and AB is 2. What is the length of CM? CM, from the drawings it's very easy to see that CM in total equals to CB plus BM. That is to say CM equals to CB, that is 8, plus BM. So in total CM equals to 8 plus BM. Here CM equals to 8 plus BM, so it is CM over BM. CM is 8 plus BM over BM. 8 over 3 is 4, so in total we found out that 4 equals to 8 plus BM over BM. Here we multiplied this equation by BM and found out that 4 times BM equals to 8 plus BM. Here we subtract BM from this equation, we found out that 4BM plus BM is 3BM, that is equals to 8. So 3BM equals to 8. Here we divided this equation by 3 and finally found out that BM equals to 8 over 3 units in its length. Here this line segment BM equals to 8 over 3 units in its length. Then we focus on the right small triangle MBA. In this right small triangle MBA, according to the Pythagoras theorem, AM squared equals to AB squared plus BM squared. Again, in the right triangle MBM, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So in conclusion, we found out that AM squared equals to 4 plus 64 over 9. Here we multiplied 4 by 9 and then we divided by 9 in order to have a common factor of 64 over 9. And found out that 4 times 9 is 36 plus 64 over 9 equals to AM squared. 36 plus 64 is 100 divided by 9. So we found out that AM squared equals to 100 over 9. Here we took out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over 9, over the square root of 9, that is 3. So if we're going to find out that AM, the hypotenuse AM equals to 8 over 3 units in its length. Here the hypotenuse AM equals to 8 over 3 units in its length. Then we did another construction, that is to say, we drew perpendicular on BC in such a way that this perpendicular will be also tangent to this circle. Okay? So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular and side BC as T. We define the point of tendency of this perpendicular with this circle as K. Then we extended the perpendicular TK by straight line until it touches side DA at point L. Define your touching point as point L. By doing this construction, we created here the right triangle LTM. In this right triangle LTM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay, then we defined the center of this circle, this point as O. We define the point of tendency of tangent LT with this circle as K. We define the point of tendency of tangent AB with this circle as N. And finally, we define the point of tendency of tangent BT with this circle as H. Then we join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself. Therefore, OH is the radius of this circle. We define the radius of this circle as X. Therefore, OH equals to X because it is the radius of this circle. Then presented to you all number all 1 and you presented all 1 in our drawing. We have the radius OH, that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. Likewise, we join points O and N together by straight line. ON is the radius of this circle, is equal to X. The radius ON is drawn to point N, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and K together by straight line. OK is the radius of this circle that is equal to X. The radius OK is drawn to point K, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we focus on the small quadrilateral OKHT. In this small quadrilateral OKHT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral OKHT, we have 4 right angles. Therefore, we can relate to this quadrilateral OKHT as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, OK equals to HT, but OK is X, therefore HT must be also equal to X. Likewise, according to the same rule, OH must be equal to KT. But OH is X, therefore KT must be also equal to X. So if we found out that quadrilateral OKHT is not a rectangle but a square, because all of its sides are equal to each other. We repeated on the same process on this small quadrilateral NOBH. In this small quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore, inside quadrilateral MBHO, we have 4 right angles, therefore we can relate to this quadrilateral NOBH as a rectangle, and we know that the opposite sides of a rectangle are equal to each other, that is to say NO equals to BH. But NO is X, therefore BH must be also equal to X. Likewise, according to the same rule, OH must be equal to NB. But OH is X, therefore NB must be also equal to X. So actually found out that quadrilateral NOHB is not a rectangle but a square, because all of its sides are equal to each other. In conclusion, found out that BT equals to X plus X, that is 2X. Repeat again, if BT equals to 2X units in its length. Then we proved that the right small triangle MBA is similar to the right big triangle, triangle LTM. So write those two right triangles are similar to each other. First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles of the right big triangle LTM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to side rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that LT over AB equals to TM over BM equals to LM over AM. LT is the missing side, so we leave it as it is, over AB. AB is 2, so we substitute AB by 2. And it is equals to TM. What is the value of TM? From the drawing, it is very easy to see that Tm equals to Tb plus Bm. That is to say, Tm equals to Tb, that is 2x, plus Bm, that is 8 over 3. So in total, Tm equals to 2x plus 8 over 3. So here, Tm equals to 2x plus 8 over 3 over Bm. Bm is 8 over 3. So we substitute Bm in this equation by 8 over 3. And it is equal also to Lm. What is the length of Lm? From the drawing, it is very easy to see that Lm equals to La plus Am. Okay, so Lm equals to La, that is the missing side, plus Am, that is 10 over 3. So in total, Lm equals to La plus 10 over 3. So here, Lm equals to La plus 10 over 3 divided by Am. Here, Am equals to 10 over 3, so we substitute Am by 10 over 3. So we got this equation. Those two sides, they are equal to each other. Therefore, we get the first equation from those two sides that are equal to each other. So according to the first equation, LT over 2 equals to 2x plus 8 over 3 over 8 over 3. Okay, so we have LT over 2 that equals to 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x, so in total in the numerator we have 6x plus 8 divided by 3 and all divided by 8 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we left only with LT over 2, that is equal to 6x plus 8 over 8. Here we cross multiply this equation and found out that 8 times LT equals to 2 times 6x plus 8. Here we divided this equation by 2 and finally found out that 8 over 2 is 4, so in total this side of the equation we have 4LT. This is equals to 2 over 2 is 1, so on the other side of the equation, this side of the equation we left only with 6x over 8. So in conclusion found out that 4LT equals to 6x plus 8. Here we divided this equation by 4 and finally found out that LT equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion found out that LT equals to 2 plus 1.5x. So you can write here that this line segment LT equals to 1.5x plus 2. In the next step, we know that those two sides are equal to each other, therefore we created equation 2 from those two sides that are equal to each other. So according to equation 2, 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 plus over 10 over 3. So in this side of the equation we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to become factor with 8 over 3. And found out that 2x times 3 is 6x. So in total, in the numerator of this expression we have 6x plus 8 divided by 3 and all divided by 8 over 3. In the other side of the equation we have LA plus 10 over 3. Here we multiplied LA by 3 and then we divided by 3 in order to become factor with 10 over 3. So 3 times LA is 3LA. So in total, in the numerator we have 3LA plus 10 over 3 over 10 over 3. So in this side of the equation we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. After we cancel 3 on both sides of the equation, we have to leave 6x plus 8 over 8 equals to 3LA plus 10 over 6x plus 8 over 8 equals to 3LA plus 10 over 10. Here we cross multiply this equation and finally found out that 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divided this equation by 2. So in this side of the equation we have 10 over 2 is 5. So in total this side of the equation we have 5 times 6x plus 8. Here we have 8 over 2 is 4. So in total, on the other side of the equation, we have 4 times 3LA plus 10. Here we open the brackets on both sides of this equation and found out that 5 times 6x is 30x plus 5 times 8 is 40. This equals to 4 times 3LA is 12LA plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled. After we cancel 40, we left only if 30x, that is equals to 12LA. Here we divided this equation by 12 and finally found out that LA equals to 30x over 12, that is 2.5x. So this line segment LA equals to 2.5x in its length. Then I copied the small quadrilateral LABT in a new page with its circle inside it. The circle is described by the small quadrilateral LABT, so I copied it in a new page and we analyze this quadrilateral with the circle on it. This is a quadrilateral LABT that is copied from the original drawing. Again, this quadrilateral blocks this circle. Okay. We can implement here rule 2. According to rule 2, if we focus on the common standpoint point A, from the common standpoint point A, we have two tangents to this again, tangent AN and tangent AKN. According to rule 2, they are equal to each other. That is to say, AN equals to AK, according to rule 2. So if we define AN as A, then AK must be also equal to A because they are equal to each other. Then we focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this circle, tangent BK and tangent BS. And according to rule 2, they are equal to each other. That is to say, BK equals to BS. So if we define the length of BK is B, then BS must be also equal to B because they are equal to each other. So in total, we found out that BK equals to BS equals to B. Then we focus on the common standpoint point T. From the common standpoint point T, we have two tangents to this circle, tangent TS and tangent TH, and according to rule 2, they are equal to each other. That is to say, TH equals to TH. So if we define the length of TH as C, then the length of TS must be also equal to C because they are equal to each other. So in total, we found out that TS equals to TH equals to C. And finally, we focused on the common standpoint point L. From the common standpoint point L, we have two tangents to this circle, tangent LN and tangent LH. And according to rule 2, they are equal to each other. That is to say, LN equals to LH. Here, LN equals to LH. So if we define the length of LN as D, then the length of LH must be also equal to D. So we found out that LN equals to LH equals to D. Then we added side AB to side LT in this quadrangle ALBT. AB is A plus B and LT is C plus D. So in total AB plus LT equals to A plus B plus C plus D. Likewise, we added side AL to side BT. It is very easy to see that AL plus BT equals to A plus B plus C plus D. So AL plus BT also equals to A plus B plus C plus D. Exactly like AB plus LT, it is also equals to A plus B plus C plus D. So therefore, because of the fact that those two expressions, they are both equal to A plus B plus C plus D, we will conclude from it that they are equal to each other. That is to say, AB plus LT equals to AL plus BT. Again, AB plus LT equals to AL plus BT. See it again. AB plus LT equals to AL plus BT. AB is 2 plus LT. LT equals to 2 plus 1.5x. So we substitute LT by 2 plus 1.5x, and it is equals to AL. AL is 2.5x, therefore we substitute AL by 2.5x plus BT. BT equals to 2x, so we substitute BT by 2x. So in conclusion, we found out that 2 plus 2 plus 1.5x equals 2.5x plus 2x. 2 plus 2 is 4, so in total in this substitution we have 4 plus 1.5x, that is equals to 2.5x plus 2x is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here we subtracted 1.5x from this equation, and finally found out that 4 equals to 4.5x minus x is 3x. So in conclusion, we found out that 4 equals to 3x. Here we divided this equation by 3, and finally found out that x equals to 4 over 3 units in its length. So the radius x of this circle equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. We actually note that the area of any circle equals to pi times the radius of the circle squared. The radius of our circle is x. Therefore, the area of our circle will be equal to pi times x squared, according to this formula. X is 4 over 3, therefore x squared is 4 over 3 squared. So in total, the area of the circle will be equal to pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.